Okay, this is an interactive equation set solver in a jupyterlite Python notebook. Now I'm going to guide you through the steps to get to this point from scratch. So to really prove that we're starting from a basic jupyterlite notebook, I'm going to go to the help menu and hit clear browser data. We're going to hit clear. Now it's reloading jupyterlite. Okay, so we are in a stock jupyterlite instance right here. Okay, now on this GitHub Pages site, I have a Jupyter notebook, which you can see here. JupyterLite has an option under the File menu to load or open from a URL. Now you need the raw link to the notebook, and that's right here. So I'm going to right-click this, do copy link address. Now we'll go to the File menu, open from URL, paste in our notebook address, and hit open. All right, so there it is. Now let's make that the primary notebook we're viewing. So I'm going to close this other one, and I'll also close the sidebar here. Okay, let's work through the notebook. So in this first cell, we're installing the IPy-widgets package, which is what the equation solver uses. So I'm going to execute that cell, and it's done. The second one installs the combine equations package. So I will run that. Okay, now all the prerequisites are in place. So the rest, so this cell is, we're going to import the modules that we're using, or the functions from the modules that we're using. That's it. Here's just some markdown. So this example is taken from a physics textbook called University Physics, 5th edition. I'm sorry, 15th edition, and it's exercise 221. So there's a description of the problem. In this cell, we are setting up the problem. And here, if you read the description of the problem, we have some numerical values. So these are specifying the values that we know. Now, this function here just displays the equations that we've built up. So using this setup right here, we end up with a variable called EQS. Those are the equations, and we can display them. These were intended for use with a regular console, and so they display like this. And what you can see there is the value that we want is in red, the values that we have are in green, and everything in black is unknown. And so we can use solve and display function. If we execute that, you can see there it solves it symbolically. So there's the first line. You can see what's in red is on the left, right? And then the numerical solution is shown after that. And similarly, so that was taken care of part A. And then in part B, down here, that's this, well, it's the same set of equations, except now I'm saying I want this symbol, so that one's highlighted in red. And then we also we can do solve and display, and same thing. Now it's giving us the solution for part B. So that's working through the problem using the solve and display function, which kind of does all the work for you in terms of solving the set of equations for the symbol that you want in terms of values that you have. But sometimes it's nice to eliminate variables from an equation manually, and also to isolate them manually, so that you get a little more intuition for the set of equations you're dealing with. So in this cell right here, let's call show equation GUI Jupyter. When we run that, we'll see this equation viewer and manipulator, and now we can see our 4 functions displayed here. And similarly, the red symbol is what we want, and green is what we have, the numerical values for. So in this third equation, we can see it has the symbol that we want. The only thing that's not known is this DT symbol. Now if I click on DT, every instance of that symbol is highlighted. And so we have a couple of, it's in this first equation and it's in the second equation as well. So there's a couple of ways we can go about this. What I'm going to do is I'm going to take this velocity variable, right click on it, and select eliminate, so that we're going to eliminate that symbol. So I click on that. Now we get a new set of equations where that velocity symbol has been eliminated, and so instead of 4 equations, now we have 3 equations. And eliminated just means, like for example, if you look at this equation here, we have the velocity symbol on the left. On the right hand side we have this expression, and so what eliminate does is it takes this expression and substitutes the velocity symbol with that expression anywhere it is in the equations. So this expression basically moves into this instance of the symbol, right? And then we can get rid of this second equation. Okay, so now if we look at our second equation, that has the symbol we want. The unknown is this dt symbol here. The dt symbol appears in both the first equation and the third equation. Now in the third equation, everything else is green. So we can essentially solve that third equation for us, the symbol that we, the dt symbol. So what I'm going to do is I'm going to right click on the dt symbol, and so this time I'm going to select eliminate dt using the third equation. So I'm going to click that, and there we'll see our new set of equations. Now we only have 2. And now we can see we have our fully symbolic solution for the symbol we were looking for. Let's load up another instance of the equation GUI with, this time we're going to highlight the symbol that we want that's specified in part B. So let's run that. And okay, we have a new version of the equation GUI. And there we can see the dt symbol is highlighted. So what I'm going to do is this time I'm going to, similar to last time, I'm going to highlight the this velocity variable. I'm going to do eliminate, and we get our new set of equations. Now looking at this, in the third equation, what we want is in red, everything else is in green. So it's pretty much already solved. We just need to isolate the dt. So I'm going to right click on the dt symbol, and I'm going to do isolate. Now in this in the result we can see that we have 3 equations, but in the third equation has now been rearranged so that the dt symbol is on the left. All right, thank you. Let me know if you have any questions or suggestions.